Hi everyone, we are going to talk today about one of my fun Makerspace activities that is set up for K and older actually. And as I'm kind of giving an introduction, please be mindful of the video down to the bottom right corner. It is showing how some of these robots are working in action. It's a little hard for us to do this virtually without having the robots in your hand. If you attended NCBOLD, we actually use the robots to code in the class with us. So I'm going to kind of go through and kind of tell you how we did this and why I think it's important. The first one you just saw was our Indy robot. He was our easiest robot. I used him with pre-K and kindergartners. And then as we get a little bit more complex, we have our Dash robot. And he uses a little more reading skills and knowledge as far as being more precise with block coding. And then in a few minutes, you will see the Sphero robot. But as you can see right here with Dash, and these activities can be completed with any robot. You don't have to think, oh, that you used Dash on that one, so I've got to use Dash on that one too. But you can see here they created a bee. We were talking about pollination, and they actually coded the bee to go to the hive. And they were actually using measurement and problem solving and I like to say failing forward where they wouldn't get it right and then go back and try again. They love it. And the fact that we kind of implement it with Makerspace, as you can see, there's a bee on top of our robot in that picture where they had to create a bee with certain criteria like the 6 legs and they had to be a certain length and width. And this is actually the Sphero. And they are making a perimeter of a Christmas tree, and that's for our oldest learners, and it goes all the way up. I would start that with like the end of 2nd grade, but you can go all the way up to high school with the Sphero robot. So the purpose of this session is to actually immerse yourself in thinking creatively in your STEM lab and using the engineering design process to actually build background with text first, and then taking the text, putting it into a Makerspace activity with actually make and build from everyday recyclable materials, and then take that object that you've made and put it into a robot to make the robot do what we ask it to do. It makes the activities more meaningful when they have some actual content behind it. So today, I'm hoping that you will be ready to go out and maybe write you a grant or use those robots you've had packed away in your closet for some time. It's really engaging and exciting, and the kids learn so much with problem solving by using these robots. So we always start our Makerspace with the engineering design process, and many of you have heard of this. All of our activities are based around these 5 steps. Ask, what's the problem? And how can you have you seen people how someone else has already solved the problem? In fact, you already know. Imagine brainstorming some solutions, talking with your team, maybe deciding which plan might work the best, and then actually making the plan and giving a job to each person in your team. And then we have the create step, which obviously is their favorite. And then obviously we always forget this sometimes, but it's so important that we teach the kids, even if you think you got it right the first time, there's always ways to improve. So how can you make it better? Redesign it, make it better, try again. And if you don't get it right the first time, that's a learning lesson. Let's try again. We don't want to give up the first try. And coding with the robots teaches kids a plethora of skills, from risk-taking to creativity to problem solving and teamwork. Oh, perseverance. I can remember when we first started coding and doing Makerspace in the STEM lab here, the kids were so upset when they couldn't get it right the first time. They're not used to having something that's so difficult. They have to try again. So I really encourage you to reach out, try this with the kids, and tell them it's okay. Take a break. I promise you, before it's over, you will figure it out. And almost every time they do figure it out. So we start at the beginning. We start with Coding Unplugged, and down here at the bottom on the right, you're going to see a Teacher Pay Teacher resource. It's a free resource that I use to help kids understand what coding is and what it means. And we take a little bit of time. We talk, and the slideshows are all linked on every slide up here. We talk with the kids about what coding is, what computer programming is, and we talk about it as a series of steps. And if you go through the steps, if you click on the slideshow, each slideshow has some videos included and some things to help you kind of walk through this. There's literature included in it. This is a really fun story about how to code a sandcastle. And it just talks about a little girl who is taking her robot to the beach, but she wants to build sandcastles, but she also wants to play. And then we go into the real life reason that we have robots to begin with is to help us and to make our life easier. And the robot does help her, but he gets a little confused because the steps that she gives this robot are not very clear. Like she'll just say, go make a pile of sand, and then he'll make the pile of sand, taller than she is, and she can't build with it. Or he'll say, go get some decorations, and he'll go in the water and get a living crab and try to put it on there. So we talk about how specific directions need to be here. This is so much fun. I have these cards, and you can print them out. They're on the first slide, but it's basically hopscotch dance party. So one student will be the robot, and one student will be the engineer, and they have to develop the code in the block codes of what they want the robot to do. And the robot can only do what's in the codes. So that's fun. It kind of gets their hands off, and they can kind of see what all that means. Super fun. We follow up with some different videos that talk about computers and some science behind it. So that's the way we start. Totally off computers, hands-on, no robots allowed, just understanding what is coding. Then we get to actually use our fun robots. So we have 3 different robots here at the primary school. Indy is our easiest robot. The only thing that he is going to use are these mats, and the mats, each mat is coded to mean a different thing. For example, green will mean go straight, pink might mean turn left, and red might mean stop. So the kids can make their pattern or their code, and the robot will do exactly what they told them to do. And I like to set up obstacles for them. So let's just say you start at one spot. One thing we like to do is during Fire Prevention Month, we talk about how we got to get the fire truck from the fire station to the fire, right? So they have to make the path, and they can build their fire station with Legos. There's your Makerspace in here if you wanted to, or even cardboard if you have the time. And they had to make the path to get to the fire, which is super fun because they think, well, I wanted it to go left, but, well, you put down the pink meant go right. So you have to go back and make changes and talk to each other and problem solve with that. Our block robot is our dash robot. He's actually where you get into the block coding. We use iPads with him, but you can use Chromebooks, and it's connected with Bluetooth, and you actually write the code, more specific, a little more deeper knowledge, but still super user-friendly, even for the first graders. And by the time they get to second grade, they're ready for our Sphero, and he's our most complicated robot, but he can also do the most. So don't think second grade and beyond. I'm thinking high school can really get some use out of the Sphero robot. Possibilities are endless in what this robot can do. So the next slide is tips and tricks for each robot. I wish you could have this in your hand right now and actually use it and play with it, because I think you'll see how simple it is when you can actually put it on the floor, turn the power on, lay down your codes. But I've given some tips and tricks for each of the robots. When you do decide to pull those out of the closet or use that grant money to get one, that come back to these pages, because it'll really save you some time on why things aren't working exactly like you think they should, because that was kind of part of the learning curve with all of us on that. The same thing here with Dash, more tips and tricks. We start basic. Like we focus just on going forward, going backwards, and make right-hand turns, because it automatically defaults to turn right 90. But then once they get really good at it, I'll say, okay, that is great. You're wonderful. And now I'll put another piece of tape down, and I'll have them do an angle where they have to actually figure out what the turn is, and it's not 90. And even though they're little, they're second graders, for example, they're still able, maybe they don't understand right angles and 45-degree angles, but they can guess and check to figure out, okay, that needs to be a smaller, and it needs to go in some more, go out some more, and it's still the problem solving that you can still use that, even though they're not old enough to technically do angles, but that's okay. They can still do it. Sphero, he has the most options, right? So the thing that I would say about that one was to aim it each time. All of these things are here for you to look at. And with the Sphero robot, when you're going a path and you say go straight, and then you might tell it to turn right, and you end up doing that, it ends up making more like an oval. So my biggest tip here would be, say, when you go right, then I want you to stop. So we add a delay in our code, and then we turn. And that's been a big help, so that it makes a more sharp turn. kind of like how I tell the kids, like riding your bike, when you get to a stop sign, you stop and then you can make your turn. Otherwise, you're going to be doing more of a curve. So the next few slides have tons of different units that we do in media and STEM. We have a 4-day encore rotation with them in here where they can actually use literature and Makerspace to make and then create. So one of them here was the creepy crayon. Around Halloween time, we love to do these, and creepy carrots and creepy underwear. And in this one, they're actually going to sequence the events in the story. And there's actually, when I click on this picture, you can see all the lesson activities are here for you. But getting to the robotics part, we talk about how sequencing events is like making a code. So you have to put the events in order. So we put the events of the story in order, and then they have to take the masking tape, put it down along the code, and they have to make the code to follow the path. Good way to kind of relate sequencing with literature and also with engineering and coding. So then we go to all of the other reindeer. This is a really fun one as well. And this one, the reindeer decides that he's a dog, but he really wants to be a reindeer. So we talk about, we had to make a reindeer. And if you click on, let's back up one, click on the book, it takes you to this actual slide deck. You can feel free to use them, copy them, change them any way you'd like. But after we read about that, we make Olive, actually. We make a freestanding reindeer that can stand all by itself. So that's materials. We have stipulations they have to use. They go through the engineering design process to make it. And once they've done that, then we can we make the house they're going to go back to, 3D shapes. This is all included into the curriculum, where they make the house that he's going to return back to. But then they have to code Indy to follow the path. And if you look here, you can see on one of these slides, you can see the actual reindeer they had made and some of the paths they had taken with them. So that's super fun too. Dolly is fun. Then we go, now remember, like I said earlier, you don't have to be limited to one robot. Any of these robots can work with any of these. And in this story, I love to connect to literature, they have to make a doll. And obviously it has to fit into the stipulations. And in this story, the little girl wants to make a doll robot to take her dog for a walk. So she actually makes the robot. And I have found nothing is better than a solo cup. Solo cups can fit right on top of the Dash robot, and then now your robot has turned into a doll, and they have to code the doll to take Indy or take Dash, whichever one you decide to use, for a walk, and you can code the path that way. You saw this in the beginning where they were we talked about bees and pollination and all of the good science part of STEM. And they actually, in media, they write cinquains about spring and bees, but then they actually code the bee to go from the hive, to the flower and back and spread pollen, that kind of thing. Bear came along, it's the same thing. The lessons are here attached for you, and you are able to go in and do sequencing again with this one, with all the animals that Bear came across as he's going on his journey. Balloons Over Broadway is super fun, especially around Thanksgiving and the Thanksgiving Day Parade. And they actually make a balloon, and they let their robot let it controlled by the robot versus people. Iditarod race is super fun too. We kind of use a scenario that, okay, the dogs are off this year. They cannot race. So we have to find a robot to take the mushers on this adventure during the Iditarod dog sled race. And all the lesson slides are here for you, which you can see down here in the bottom circle where they're actually making an Iditarod. And they attach it. In this situation, they used the Sphero robot. And it's very interesting because they want to make these really elaborate sleds. But then what happens when they go and test it and put it on the Sphero is too heavy. And they have to go back and make changes to make it lighter, because then the robot doesn't have that much power and it cannot pull the weight of what they've created. So that's a good way of talking about going back and trying again and things get hard. I love this. This is kind of the same idea as behind the chariot, but behind the Iditarod, but it's a chariot this time, like studying fairy tales, and they make the chariot for Cinderella. Same idea, different book. Matter. This is really fun too. When you have them work as a team and we talk about molecules and solids, so the molecules are close together, and liquids where they're totally apart and don't touch, and gases where they don't touch at all, and liquids where they kind of touch very intermittently here and there. And they have to figure out how to make their robot move following the stipulation of what kind of object it is, solid, liquid, or a gas. Super challenging, but good problem solving. This is area and perimeter, and this is why our Sphero has a lot more capabilities than the other ones. So this is for our third graders, where they actually have to, you can code it down to decimal points to make it exact, so you can follow the different points on the line. Wow, mapping. Bring out that big map. Pull out your robots and have them find a track from one region to another. Super fun, related to the curriculum. And look at how they're getting to see places on a map. So the rest of the time was spent in this session actually going through and get the chance to play with each of these robots and explore them. And remembering that the idea behind the lessons can work with all three robots. You can pick which one works best for you, but which one their kids are ready for. If you know your kids are ready to pass on from Indy, or you don't have an Indy and you only have a Dash, please feel free to modify any of these to use what robots you have. I hope you enjoyed, and if you have any questions about the robots, please email me and I'll be glad to walk you through it. I'd love for you to come visit us. You can come play with our robots, and we hope to talk to you soon.